So we've got a question here that is stoichiometry, but it links back to redox. So we've got iron oxide reduced by carbon monoxide to produce molten iron according to this equation. So, according to the equation, how many moles of iron can be produced from 1 mole of iron oxide? Here's our iron oxide. So if this turned into 1 mole, that means we've divided it by 2. So that means everything's going to divide by 2, including this. So we're going to land up with 2 moles of iron oxide. Done, 2 moles. All right, how many moles of carbon dioxide can be produced from 2 moles of iron? So let's write down that part of the reaction. We've got 4 Fe and then 3 CO2. So we've only got 2 moles of iron. I'm going to divide this by 2. And that means this is going to divide by 2. It's going to halve. So we're left with 1.5 moles of CO2. Done, that's the answer, 1.5 moles. How many moles of iron oxide would produce 0.6 moles of carbon dioxide? So let's write that equation back up. All right, written up. So what has changed is this has become 0.6 moles of CO2. So we need to think 3 times what will get us to 0.6. And we can find that by doing a little division here, finding a mole ratio. Fancy that, it lands up being 5. So we're going to divide everything by 5, including this 2. So 2 divided by 5 is going to land up being 0.4. So we need 0.4 moles of Fe2O3. Remember, you've got a calculator, so don't stress about these calculations. Boom. How many moles of carbon dioxide are produced from 0.6 mole of iron oxide? Once again, let me write down the equation. All right, so we have got 0.6 mole here. What is the mole ratio? I'm going to do 2 divided by 0.6. We're dividing. So we have to divide by 3.3333333 to get to 0.6. So we're going to do the same to the other side. 3 divided by 3.33333. Sounds really funny to say that again and again. And when you do that division, we land up at 0.9. Fancy that. That's nice. So 0.9 moles of CO2. Done. We got one last one. All right, I've written up the equation. How many moles of carbon monoxide produce 2.8 moles of iron? All right, first of all, let's find that mole ratio. 4 divided by 2.8. It comes to 1.43. I'm going to round that up. So 4 divided by 1.43 will get us to 2.8. So we're going to divide this 3 from the carbon dioxide divided by 1.43. 3 divided by 1.43 will get us to 2.01 moles of CO. So I know these are weird values of moles you might have not seen before. Oh, actually 2.1, I rounded it wrong, my bad. But it is possible when we are looking at stoichiometry to have some interesting, should I say, mole amounts. Not your traditional ones you're used to seeing in a reaction. So I totally could have put this on the other video. I'm kind of regretting not doing that. But hopefully you feel a bit more comfortable with these types of stoichiometry questions. So give some practice and let me know if you need any help.